Alright, so we're picking up where we left off for the fall final. Statistics were calculated from last year's STAR test as follows. 76% passed English 1, 92% passed biology, and 65% passed Algebra 1, and 88% passed U.S. history. Draw a tree diagram below. Okay, so let's say passing English, failing English. So there's 0.76 for passing English, so 0.24 for failing English. 92% passed biology. So passing biology, failing biology. Passing biology, failing biology. So there's 0.92, 0.18. 0.92, 0.18. From there, we have Algebra 1. So you can pass algebra, fail algebra. Pass algebra, fail algebra. Pass algebra, fail algebra. Pass algebra, fail algebra. And there's a 65% for passing, so 0.65, so 0.35 for failing. 0.65, 0.35, 0.65, 0.35, 0.65, 0.35. To find the probability for failing, I'm simply subtracting from 1. I change the percentage to a decimal by moving it over 2 places, and then subtract from 1 to find the opposite percentage. All right, so for U.S. history, so passing history, failing history, 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 passing history, failing history. So it's 0.88 here, so it's 0.12. Alright, so passing all exams, so the probability to pass English is 0.76 times 0.92, 0.65, 0.88. So I go to my home calculator screen, and I just multiply all of these probabilities together. 0.76 times 0.92 times 0.65 times 0.88. And I get a total probability of 39.99% or 40%. All right, passing English and biology only. Okay. So that means if you pass English, that's 0.76. Passing biology is 0.92. That means you failed algebra, so that's a 0.35. And that means you failed U.S. history, so times 0.12. 0.76 times 0.92 times 0.35 times 0.12. That is a 2.9%. Passing at least biology. So that means all we care about is biology. So the probability of passing biology is 92%. Failing all exams, so for English, that's 0.24, 0.08. Oh, I put 1.8. These should be 0.8s. I'm sorry. All right, 0.08, 0.35, and 0.12. Go over here, 0.24 times 0.08 times 0.35 times 0.12. So the probability of failing all exams is 0.08%. Going on to the next page. In a particular dice game, you pay $2 to play. If you roll a 1, so that means 1 out of 6, you win $3. If you roll an odd, that means that's 3 out of 6, you win $1. But my thing is with this odds, you have to eliminate the 1 that is also an odd. So really it's 2 out of 6. You win $1. What is the expected profit for the house per player? So I do 1 out of 6 times 3 plus 2 out of 6 times 1. I'm going to do 5 divided by 6, Control Enter. So 0.83. So is the game in number 31 fair? So we're expecting to pay out 83 cents per player, but they're paying $2 to play. So no, it is not fair. What is the expected outcome if you flip 12 coins? The expected outcome is 6 heads and 6 tails. A carnival game's first prize probability is 0.0625, second prize is 0.25, and third prize probability is 0.425. If 400 players attempt the game, about how many of each prize should the carnival expect to award? So all you do is you take the probability, so 0.0625, and you multiply by those 400 players. So 25 first prize, 100 second prize, and 170 third prize. In a standard deck of cards, what's the probability of drawing a heart, replacing the card, and then drawing a 4? So there's 52 cards in a deck. So the probability of drawing a heart, so that's 13 out of 52. And, so that means we're multiplying, then you draw a 4. So we've replaced it, so there are still 4 4s out of the 52 cards. So we take 13 divided by 52 times 4 divided by 52. So when I multiply those together, I get 1 out of 52. Next week, Anna is playing in a volleyball tournament. We'll play 5 games. To win a trophy, she must win at least 2 games. How many total possible outcomes can she have when she plays her 5 games? So she can either win or lose the first game, win or lose the second game, win or lose the third game, win or lose the fourth game, so that's 1, 2, 3, 4, and you would do it again. So really, there's 2 options that first time, and then that second time, you double it, so there's 2 options that branch off of there. Then there's 2 options that branch off of each of those. There's 2 options that branch off of each of those, and then there's 2 options that branch off of each of those. So we are taking 2 to the 5th. 32 total options. What's the probability that she will win at least 1 game? So for her to win 1 game, there's a 50-50 chance, or 1 out of 2. What is the probability of winning a trophy? So to get a trophy, she has to win at least 2 games. So 50-50 chance she wins 1 game, 50-50 chance she wins another game. So 1 out of 2, 1 out of 2 is 1/4, or a 25% chance. At Stacy's Soup Kitchen, lunch customers must choose from the following for a $2.99 lunch combo: potato soup, broccoli and cheese soup, or minestrone soup. So that's 3 options. Then they can choose a Caesar salad, house salad, or baked potato. 3 options. Then they can choose a chocolate chip cookie, a sugar cookie, or a brownie. 3 options. So how many different combinations are possible? 3 times 3 times 3 is 27. If 1 additional soup type is offered, how many additional combinations are now possible? So now it would be 4 times 3 times 3, and we're subtracting that 27 we got in the last problem. 4 times 3 times 3 minus 27 is 9 additional possibilities. What is the probability of a customer ordering a potato or minestrone soup? So potato or minestrone is 2 out of 3. House salad, so that's 1 out of 3. And then a sugar or chocolate chip, so that's 2 out of 3. We multiply these together. 2 divided by 3 times 1 divided by 3 times 2 divided by 3. And you get 4 out of 27.